Welcome back, Chemistry 30. This is the second part of the lab. So hopefully by this point you've completed the data tables, you did the experiment, you found out what was a precipitate and what wasn't, and hopefully the 10 dissociation equations. So now we just have to look at the analysis in terms of what do we do next. So I'm going to go through actually the first data table with you and leave you the second data table to do. If you're looking at the first data table, you likely got precipitates in the following boxes here, okay? And also the third page of the lab kind of outlines what you need to do with that. So I'm just going to look at that and go with that, explain it in more detail so you know what to do here. So let's just pick this box. I'm going to pick the first box here, barium nitrate with potassium chromate. If we look at that, we had something happen. So if we look at this, so analysis precipitate number one. Now, barium nitrate, potassium chromate, you did the dissociation equations. So equation 1 and equation 4 are the ones we're looking at. And as we see, barium nitrate breaks down into barium and nitrate. And potassium chromate, 2 potassiums for every 1 chromate. So of course what happened there is you had one of 2 precipitates. Could be barium chromate or potassium nitrate. So we have to look and see which one of those is the precipitate. So what you have to say here is when barium nitrate was mixed with potassium chromate, the possibilities that we got were barium chromate and potassium nitrate. So I just kind of exchanged partners, the double replacement reaction here, the positive cations and the negative anions switch. So what we have to do is look to see other boxes where these could have occurred. So if I look at potassium nitrate, where potassium and nitrate were together. If I look here, here's potassium, K, here's nitrate here. So in this box right here, potassium ions and nitrate ions would have been together, and as you can see, there is no precipitate there. So that tells you right off the bat that potassium nitrate is not the precipitate because nothing happened in that box. So that's all I said here. All I have to do is just find an instant in which that happens. So KNO3 is rejected since there is no precipitate in that box I just talked about when barium nitrate was mixed with potassium chloride. So by elimination, that tells you that barium chromate must be the precipitate, but we should just take a look here and just make sure. Barium and chromate, precipitate. Barium, 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 chromate. So you can see every instance where I have barium ions and chromate ions, CrO4 together, I get a precipitate. So what we say there is every combination that barium and chromate were together, I had a precipitate. Okay, so that's how you get 2 marks there, saying what the possible precipitates are, and then keeping one and proving that the other one is a precipitate. Okay, so the follow-up here, barium nitrate with potassium chromate. Barium nitrate with potassium chromate came together and made barium chromate and potassium nitrate. So there we have to write the balanced chemical equation. And of course I know that barium chromate is the precipitate, so I write a little S there, whereas everything else is AQ, AQ, AQ. And of course 2 potassiums, 2 nitrates, so I have to use that 2 there to balance it out. Break that down into the complete ionic reaction. So barium ions, 2 nitrates, 2 potassiums, 1 chromate, my barium chromate precipitate, 2 Ks, 2 NO3s. So of course we can see that the 2 NO3s and the 2 Ks remain the same on the other side. Cross them out, they are the spectator ions, and I'm left of course with the precipitate and the 2 ions that made the precipitate. Okay, so that's what you have to do for every different precipitate. You don't have to do it for every box, because every box in Table 1 is barium chromate. So I just have to do it once, indicating that all these precipitates are barium chromate. Okay? In Table 2, pick a box where you see a PPT, do the same thing, and I'm going to give you a hint that there is 2 different precipitates here. So this procedure of figuring out what precipitates there are in a particular box and then keeping one and rejecting the other one, you have to do it only 2 more times for the 2 different precipitates. Okay? So run through that. If you have any questions, please ask me when you see me next time. So when you're done that, then you just have to do the conclusion here. What were you going to do? Just simply restate the purpose. The purpose was to da-da-da-da-da. We didn't have a hypothesis, so this part's omitted. What did happen? What happened was the 3 precipitates were boom, boom, boom. So just simply state what the precipitates are. And then I don't have any follow-up questions. That analysis that we just talked about, that's going to be good enough. Okay? So that's all that's left in the lab. And of course, what you need to hand in, you'll need to hand in this science independent investigation sheet, as well as this, the lab handout itself, because your data tables are on there, and also the 10 dissociation equations as we see here. And lastly, if you wrote this on a piece of loose leaf, the analysis part, you need to hand it in as well. Okay, see you again.